Hi students, this is Mike Richmond, and this is a mini lesson talking about the multinomial distribution. Now hopefully you've looked at my video for the binomial distribution, because the multinomial distribution is just an extension of that thought. Got my jar of coins here again. Before I told you it was mostly pennies, 80% pennies and 20% non-pennies. Well, let's change the dynamic here just a little bit. Let's suppose my jar of pennies has, my jar of coins, I should say, has pennies, nickels, dimes, and quarters. So let me write some things down here. Okay. I've labeled these as 1 is for pennies, 2 is for nickels, 3 is for dimes, 4 is for quarters. And this is just an index, an identifier. It doesn't really mean anything, just could be A, B, C, D, could be anything you want. The reason I've done this because naming convention is going to happen in just a little bit. So let's suppose, just for the sake of argument, I've got 45% pennies in the jar. So the probability of getting a penny on a single draw of a single coin is 0.45. Let's suppose I've got 20% nickels and 25% dimes. And that would leave me with 10% quarters. Make sure that adds up, 20, 45, 90, 100, okay. So there's my probabilities of having each of those coins. And I know some of you are thinking, well, I can stick my hand in there, I can tell what kind of a coin I'm getting out. So even though probability of getting a quarter is very small, if you wanted me to get a quarter, I could. Yes, I agree with you, that is true. But that's not what we're talking about. We're talking about a single randomly selected coin without any regard to whether you can tell the difference between thickness or diameter of the coin or anything else like that. So let's just go with this. Okay, I've labeled these as 1, 2, 3, and 4. So we're going to say pulling a penny is event 1, and it's got probability 1 is 0.45, so that's probability 1. And the number of pennies I want to pull is going to be n sub 1. Okay, so the probabilities associated with each of those coins are P1, P2, P3, and P4. And the number of coins I pull is N1, N2, N3, and N4. So the way the multinomial distribution works, you remember with the binomial distribution, I said, hey, let me reach in and grab 12 coins. What's the probability of having exactly 9 pennies? Well, this is the same sort of thing. What if I reach in and grab whatever number, 8 coins? What is the probability of those 8 coins having exactly 3 pennies, 3 nickels, 1 dime, and 1 quarter? So let's have to add up to 8, obviously, because you're grabbing 8 coins. But you can calculate whatever combination of probability you want to here. And the way you do that, the formula looks complicated, but it's not really. The formula is simply, if you remember with the binomial, we had to do combinations. Well, this time we don't even have to do that. We're going to just say the probability is equal to n factorial. So n is just the total number. Like if you're going to grab 8 coins, that would be an 8. And then in the denominator of the fraction, you're going to have all the smaller n's. So in this case of the 4 coins, we'll say there are 4 different n's. So there's going to be n1 factorial, n2 factorial, n3 factorial, n4 factorial. And then you're going to multiply that fraction by p sub 1 to the n sub 1 times p sub 2 to the n sub 2 times p sub 3 to the n sub 3 times p sub 4 to the n sub 4. Okay, now again, like I say, this formula on paper looks super messy, but it's really pretty straightforward. You've got overall probability is my total count on top, and then the individual counts of the different coins on the bottom. Those are all factorials. And then my my exponentials over here are each probability of individual coins. So this is the probability of pennies, raised to the number of pennies, probability of nickels raised to the number of nickels, probability of dimes raised to the number of dimes, probability of quarters raised to the number of quarters. Okay, so let's do a problem real quick. Of course, the easiest way to do this is to use Excel. So let me share my screen and go to the Excel page. Okay, and here it is. So I've already kind of set this up a little bit. This is the multinomial probability with 4 different possible outcomes. This can easily be expanded to whatever outcomes you want. Okay, let's put the probabilities in. So I said pennies was 0.45, nickels was 0.2, dimes was 0.25, and quarters was 0.1. Handy tip, these, whether it's 3 or 5 or 26 different options, these outcomes have to add up to 1. So if I highlight all of those and I come down here, look at my auto sum, it says, hey, the sum of those is 1, so we're in good shape. We've done what we needed to do. And then the ends, so let's, let me write this down. Okay, so let's say I'm gonna pull 8 total coins, okay? So I'm going to have, I want to find out the probability of drawing out, what did I say? I said 3 pennies, 3 nickels, 1 dime, and 1 quarter. So those, that's kind of hard to see because that's really small there. So those are my total probabilities, 8 total coins, 3 pennies, 3 nickels, 1 dime, 1 quarter. Okay, now all I got to do is plug these in here and create a formula. Let's see. Okay, so I'm looking for 3 pennies, 3 nickels, 1 dime, and 1 quarter. And now finally the probability, and this is going to be kind of a lengthy, hairy formula. Okay, that's going to be equal to, first of all, I want to have the total n on top. Well, I don't have the total n anywhere. I've got all these sub n's, as pennies, nickels, dimes, and quarters. I don't know the total number of coins. But surely, if I just add those 4 up and do the factorial of that number, I should get what I'm looking for. I'm going to say factorial. And then inside the parentheses, I'm going to say this plus this plus this plus this. So the factorial of those things added together, I'm going to add them first and then do the factorial. So that's factorial 8 in this case. Then I'm going to divide that by factorial of pennies, factorial of 3 times factorial of nickels times factorial of dimes times factorial of quarters. Okay, now so just to make sure my order of operations stays the way I want it to, because I think the way I've got it written out here, it's not going to work. It's not going to give me the right answer. I need to stick a parentheses here in front of the factorials in the denominator, and here, so it'll calculate all those together before it does the division. Okay, so this is one of those cases where if you're really sloppy or lazy about doing formulas in a linear fashion, you can really get way off base really quickly because it'll calculate something that you don't think is supposed to be calculating. Last but not least, I'm going to put parentheses around the whole fraction here because I want to calculate that fraction first before I start multiplying it by, and I'm going to do parentheses here also, so it's going to be 3 raised to the 0.45, close parentheses, times 3 raised to the 0.2, close parentheses. Whoops, I missed a parentheses in there somewhere. So I need a parentheses right there. Times, open parentheses, 1 raised to the 0.25, close parentheses, times 1 raised to the 0.1, close parentheses. Okay, hopefully I haven't made any mistakes here, and this should come out. It's going to be pretty small. I'm going to tell you right now, it's going to be pretty small. Okay, hit enter. That's not right. Okay, we've made a mistake in here somewhere. Let's see. Factorial of 8. Okay, let me break this out just a little bit. Let me call this part the fraction part. And I'm going to just say this is, I'm going to make that the same thing here. Oh, shoot, it's not going to do that for me. Okay, I'll delete that. Okay, this is going to be equal to factorial of, let me do this again real quick, plus this, close parentheses, divided by open parentheses, factorial of each of the individual ends. Need a parentheses there. Close parentheses times factorial this times factorial of this times factorial of this. Okay, and then I need to do the exponents parts. This is going to be equal to 3 raised to the 0.45 times 3 raised to the 0.2 times 1 raised to 0.25. Missed parentheses there, I can see. Times open parentheses 1 raised to the 0.1. Okay, and it I can see what I've done now. All right, I did n raised to the p. It should have been p raised to the n. So let me change those around here. Let me go back to this original formula and change those around. So this right here should be this raised to the n. And this should be probability raised to the n. Okay, so can you see what I've done here? Instead of doing p raised to the n, I did n raised to the p. So that was a silly mistake on my part. It's okay, got it figured out. We can get it solved and fix it. Okay, there, that's much better. All right, I can get rid of this thing. I don't need it anymore. I expected it to be small, and it was 0.02, so there's about a 2% chance if I grab out 8 coins out of that jar that had the prescribed proportions of coins in it, the probability that I get exactly 3 pennies, 3 nickels, 1 dime, and 1 quarter is pretty small. It's 0.02. Now, on the binomial distribution probability calculator, we kind of threw it out there. Hey, well, you know, what's the probability of 8 or 9 or 10 pennies? Well, that's easy. I can calculate 8 or 9 or 10. This becomes a lot harder because you can't really do that with a multinomial. Well, you can, but it would be very excruciating. For instance, you grab out 8 coins. How many ways are there to get 8 coins? Well, there's a lot. You could have 3 pennies, 3 nickels, a dime, and a quarter. You could have 4 pennies, 3 nickels, a dime, and no quarters. You could have 5 pennies, 2 nickels, 1 quarter, no dimes. You can see the possibilities are not endless, but they are very, very large. So the ability to, like saying something like, hey, what's the probability I grab 5 or more pennies and we don't care what the other coins are? That would take a long time to calculate that and figure that out. So multinomial distribution is kind of fun to play with, kind of cool to see what happens. But in practical terms, it's not very practical to use to answer a bunch of questions. Anyway, so with a slight hiccup, that's the multinomial probability, and hope this was helpful to you. Thanks very much. Bye.